Okay, welcome everyone. Thanks for coming. This is the week 8 webinar of the stats class. And today what we're doing is I'll start out answering any questions, just like always. And then after that, we're continuing, as I mentioned last week, is that pretty much the rest of this entire class, we're doing hypothesis testing. Last week, we looked to test for a proportion, to test for a mean. And this week, we're going to be comparing two different proportions and comparing two different means to see if there's a difference or if one's bigger, etc. And we're also actually going to be doing confidence intervals too. And just note, we'll start with proportions, then we'll get into means with independent data, means with dependent data. And then finally, I'm going to go over the expectations and the requirements for project 2, because really project 2 is all about this chapter that we're talking about today, where we're comparing in particular two different means for the data, okay, and for the population in the end. So that is the plan today. I want to remind you it's week 8, and week 8 is an even number. Why is that important? Hopefully you all know. So we're in week 8. Yeah. So it's an even week, and even weeks are when the exams are. So there is an exam. So make sure by the end of the week, you get that exam done. And there's only a few more after that. There's 8, 10, and 12. And then we'll be done. So hopefully it all goes well. And just a reminder, now hopefully getting used to it, like all the rest of the exams. This chapter 10 and also chapter 9 will be the main focus of the exam, but then about half or so will be chapters 1 through 7. And that's how the exam works. And the last few questions are hand graded instead of computer, generated graded. So you have to wait a few days before you get to find out how you've done those questions. Are there any questions about anything? Any questions? Okay, the good news about this particular week is that if you understood last week's material, this week isn't that much different. So there's not too much more to learn after last week. If you didn't understand last week's, then the good news is that you have another week to go and really, get through that, because it's just more hypothesis testing. It's all the same stuff. Now we just have 2 means and 2 proportions instead of 1 mean and 1 proportion. So what I love about stats is that I can just go online and find some news article or whatever for an example of whatever we're doing, okay, and all kinds of applications. So I'm going to start out with an example that I was able to find, and this was recently conducted, and I found it. I just went up to news and did a search. And here's the question for you. Is there a higher proportion of road rage in California than in Nevada? Okay, 200 Californians were surveyed and 200 Nevada residents were surveyed. Okay, this was a Forbes study and it was done recently, and use a 5% level of significance. Okay, so if you don't know Tahoe at all, just let you know that I'm at the college right now, and we're in California, but literally in less than an hour, I can walk to Nevada. So that's why I chose California, Nevada. The article that I looked at, the study that I looked at, actually looked at every state. But at least for Tahoe, we care about California versus Nevada because that's where we are. Okay. So then in the study, they found that 19.5% of those 200 Californians that were surveyed said that they have experienced road rage recently. Okay. And on the other hand, only 16% of Nevada residents experience road rage. So it looks like California is higher, right? Can we just say so? What do you think? 19.5% is bigger than 16%. Can we say that? What do you think? You can pop in the chat box. Okay, I say yes, California. Okay, the answer is we need to do more work to see if it really is. And the reason is they only looked at 200 Californians and they only surveyed 200 Nevada residents. So, you know, these are big states, especially California is huge. But is 200 a large sample? And this is pretty important because we want to look to see what kind of study this is. And in particular, the question, the survey question is, have you experienced road rage? And that's a yes or no survey question. Okay, it's a yes or no survey question. So we're talking about proportions, not means. And if you remember, with proportions, you have to do a much bigger sample than with means in almost all cases. So it's 200 is not that big a sample size. So we'll find out. You know, let's look at this level of significance and let's see if the p-value is going to be smaller than the 5% level of significance, or will p be less than 0.05? Because that's really what we care about. So the next thing we do is we decide on the null hypothesis and we decide on the alternative hypothesis. So the null hypothesis, H not colon, we talked about that last week, is that you always write H sub 0 colon. And then this is what's new. We now have two proportions. Oh, I got to change the letters, sorry. P sub C, because it's the California, the proportion of Californians who had road rage is equal to P sub N for Nevadans. And that is H naught, the population proportion of California residents who have experienced road rage is equal to the population proportion of Nevadans who have experienced road rage. Okay, notice, and I want to say it again, is that population proportion, that's what this P is. If you don't use the word population and specifically refer to the population on the exam, for example, and on the exam and also on, for example, the discussion post assignments, I do take off points. Make sure you do, and I took a lot of points off when I graded your discussion posts if you didn't have the word if you didn't specifically refer to the population, because hypothesis tests are all about the population. They're not about the sample. So H1 is going to be P sub C, the population proportion of Californians who have experienced road rage, is in this case not less than, but greater than, because the question is there a higher proportion in California than Nevada? And the word higher than means a greater than sign. Okay, it's really important to get that down. And then that should be greater than P sub N. Okay, it's not the number of Californians, because that's definitely higher because there's so many more Californians. It's the population proportion of them, of each of the two states. Any questions? Any questions on writing down the null hypothesis and writing down the alternative hypothesis. Any questions? I do want to also note, these are in symbols. You must use symbols. Okay, you must use symbols. Okay, if you're having trouble figuring out how to use symbols, you can write it somewhat differently. For example, you could write H not colon and then P. You could do sub, that little subscript C equals P subscript N. So I will allow those kind of symbols. It doesn't have to be perfectly done, but I don't want to just see a sentence. For example, in the discussion post assignment and the exams, you must use symbols when you're writing the null hypothesis and the alternative hypothesis for both chapters 9 and chapter 10. Any questions on that? So again, if you don't know exactly how to make the symbol, maybe you don't know how to use the Canvas equation editor, then you can do what I just did, use type it kind of with symbols. Any questions so far? All right, any guess on how we're going to find the p-value? Any guess? And hopefully you can guess. Should be an obvious way. How do you think we'll find the p-value? Using t dash? No, not quite. We're going to go to my calculator. And we're going to find the calculator in this calculator. It's much better than any kind of handheld calculator, by the way. How are we going to, what calculator number do you think is going to be good for this particular hypothesis test? Number 12. Number 12 was great last week, but notice this word A right here. I know it's a small word. Confidence interval for A proportion. We're looking at not one proportion. Remember, our H naught is that PC equals PN. So 16, that would be A proportion. 19, two proportions. Good. So now we're going to be doing two proportions. Okay? Because we're comparing two different proportions. And then it's real simple. Sample sizes, if you remember, they were both 200. The first sample was 19.5%. Okay, you could use a calculator to find it, or you can do it in your head like I do. 19.5% of 200 is 39. So that will just be 39. And the second, if you remember, was 16%. 16% of 200 was 32. Okay, you could also just, type that in a calculator, but those are, when 200 is an easy one. Had it been 193 or something, good luck doing it in your head. But 200 is good. You just double the number. Okay, any questions on that? All right. Sometimes we call it pooled when we're doing a hypothesis test. But not always. I'm going to go not pooled. That's more typical. It's a little complicated. And confidence intervals will usually not be pooled. So we don't have a less than, we have a greater than. Let's also do a confidence interval. How about 95%? So 0.95, standard confidence interval, confidence level. Any questions so far on how to use this calculator? You just calculate. And there's our solution. Notice, by the way, a few things. It uses a z, which means that we have an approximately normal distribution. And notice that our sample size was 200. 200 times 19%, or the number of successes, NP, was 39 and 32 for NP. NQ, if you subtract from 200, 200 minus 39 is 161. 200 minus 32 is 168. And those are all bigger than 5, 39, 32, 161, 168. So since they're all bigger than 5, we're actually allowed to do this. If they weren't all bigger than 5, then you really can't even do a hypothesis test for proportions. So that's important to note, is that you should always check to make sure the sample size is big enough, and it is. And it's the same as last week and the week after. The only new thing is now we just have 2 samples to check. First sample and second sample, or in our case, the Californians and the Nevadans. Any questions on that? Okay. So now that we know that we are allowed to use a normal distribution, then all the stuff is going to be useful. The p-value is about, let's call it 0.18. So the p-value is 0.18. Any questions on that? Okay, and then just note, lower bound, upper bound I'll do in a bit, but in particular, we have the graph, looks like a normal curve. Had they been the same, then they differ by 0. What we had was a difference by 3.5%, or 0.035 for the proportion. Notice that that's not in any rejection region for anything that we're going to use in our class ever. Any questions on that? All right, so now we're ready to state our conclusion. So we can go ahead and write the conclusion. Okay, the p-value is 0.18. So what do we say? What's the first words of what we should say? Any thoughts? How do we start? So how do we start for the conclusion for a hypothesis test? So first few words. Let's see, jumping in. Maybe I'll start typing them. There is, same as last week. Statistically, is it significant or insignificant? For this study? Let's see, jumping in. Notice that our p-value is 0.18. Our level of significance was 5%, or 0.05. 0.18 is bigger than 0.05. When the p-value is larger than the level of significance, there is statistically insignificant evidence. Does that make sense? Notice I'll even write p-value 0.18, which is greater than 0.05, to determine whether or not. And then the easiest is I can copy and paste the question. And then I'm going to make one little change. So whether or not there is a higher population proportion of road rage in California than in Nevada. Any questions at all on the conclusion? And I want to give you a reminder, this is a very fancy way of saying, well, we did all this work, we did the survey, we did the calculations, and guess what? We know nothing. That's all we can say. Really, we know nothing. In fact, it might be that just the issue is 200 is way too small sample size. That's a small sample size for proportions. It might be that really Californians do have more road range, higher population proportion. Might be that they're the same. Who knows? Okay, we really don't know. That's all we can say. It's a fancy way of saying we don't know. Any questions at all on the conclusion? Okay, let's interpret the p-value. And it's going to be very similar to what we did before. Last week. When I say before, I mean last week. We could say, basically you say, if the null hypothesis is true and you conducted another survey with the same sample size, then the p-value is the chance that your new survey would end up with something as extreme as what we just did. So that's in general, but you need to do more than in general. A lot of you are just doing in general stuff, I noticed on the discussion post assignments. So you can say if, and then we restate H naught in words, the population proportion of Californians who have experienced road rage is the same as it is in Nevada. And if we surveyed another 200 Californians and 200 Nevadans, then there would be and our p-value is 18, so 18% chance that the new study would have the sample portion of Californians who have experienced road rage at least, and it's 3.5%, because notice 19% is 3.5% more than 16%. So at least 3.5% higher than the sample proportion of Nevadans who have experienced road rage. Any questions on interpreting the p-value? Any questions? Okay, so now we need to interpret the level of significance. Now, if you remember last week, I mentioned that the very beginning is the first half is exactly the same. All the way up to there would be A. So I'm going to copy and paste. And say if the population proportion of Californians who have experienced road rage is the same as it is in Nevada, and if we surveyed another 200 Californians and 200 Nevadans, then there would be A. Now the level of significance, remember, was 5%. So it'd be a 5% chance that we would end up falsely concluding that basically same conclusion. That there is, I lost the is here. There we go. That there is a higher population proportion of road rage in California than in Nevada. Any questions on interpreting the level of significance? It's very similar to the p-value, at least the first half is. Then it changes, but the first half is exactly the same. But then it's falsely concluding that H1 is true for the level of significance, whereas a p-value is the probability of ending up with something as extreme as what we have. Okay, let's also do the confidence interval. And if I go to the calculator again, you'll see the lower bound was about 0.04, and the upper bound was about 0.11. Sorry, negative 0.04 to 0.11. So let's write that out. Any questions so far? That's what the calculator gave us. And as I mentioned, the picture is right here. Here's our 95% confidence interval. And it means 90% of the area under the curve in between those numbers is all of that, is that 95%. Okay, so then we need to interpret the confidence interval. And that is with 95% confidence. The percent of all Californians who have experienced road rage is between, and we could see that it's 4% lower and 11% higher than the percent of all Nevadans who have experienced road rage. Any questions at all on looking at this confidence interval? Any questions? You know, always feel free to ask questions whenever you have them. Any questions? Okay, so again, you're going to be responsible for doing this, so make sure, you know, if there's anything, please ask. Okay, let's go to the next example. And this example, I kind of slowly typed all of it. The next one, I've got it all, you know, written out, and I'll read through it. It'll go a little faster because it's kind of the same idea, but not exactly the same. So the next example is, do single women spend more time cooking than single men? Okay, maybe, maybe not. The only way you could find out is do a survey. So the 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the confidence, the 95% confidence interval. Okay, so again, the thing you should always do, especially now that we're getting into more and more of these, is read the question and then decide what kind of hypothesis test or confidence interval are we doing. Here, notice that we're comparing men and women. Okay, so it's gonna, and we have two samples, and that's important to look at. We have two samples. The other thing is a survey question is, how many minutes a day do you spend cooking? And the person might answer 68 minutes. Okay, they're not going to answer yes, they're not going to answer no, they're going to answer with a number. And because they answer with a number, now we're talking about means, not proportions. Any questions on that? Okay, so we're going to do a hypothesis test for two means. And I want to mention one more thing. These were 35 single women and 38 single men. Really have nothing to do with each other. These are not like couples or anything like that. And that's important to note. When you have them, you know, the first woman has nothing to do with the first man, we call it independent. We've talked about that before, but it's really important in this chapter to understand the difference between dependent and independent. And these are independent samples. All right, so H naught is mu sub W equals mu sub M, or the population mean time cooking for women, for single women, is equal to the population mean time cooking for single men. And the question is, do single women spend more time cooking than single men? So H1 is mu sub W is greater than mu sub N. Population mean time cooking for women, single women, is greater than the population mean time of cooking for single men. Any questions on that? All right, we need the p-value. So then we have to go to the calculator. Let's go back to the calculator menu. What calculator am I going to use? Which calculator should I use now? So what calculator? Let you read through the calculators. Tell me the calculator number to use. It's very important. If you use the wrong one, it's going to be a complete disaster. So what calculator? Okay, we're hearing 16. 16 is a hypothesis test for proportion. So first thing, we're not talking about proportions, a survey question. How many minutes do you spend cooking? The answer is not yes or no. So it's definitely not about a proportion. So what do you think? Okay, 17 is two independent samples with data. That one doesn't work with our data. Good, good. Now you got it. Two independent samples with statistics. We have statistics here. Okay. If you look again at the question, we don't have all the people's answers. We have the average and the standard deviation. Those are statistics. And then we have independent data. So that means we're going to go to number 17, two independent samples with data. And then, oh, sorry, I said data with statistics. So number 18 is what I meant. And two independent samples with statistics. Our sample sizes were 35 women and 38 men. So 35, 38. Our sample means were 58 and 46. Our sample standard deviations were 12 and 16. Our H naught was that the population mean for women was greater. So greater than the population mean for women, for men. Our confidence level is 0.95. Any questions so far? And I hate calculate. And there's everything we need. The test statistic, by the way, 3.64287-ish. P-value 0.00026. Okay, way over here. No question about rejecting the null hypothesis. We're deep in the rejection region. Even how we use 0.01 instead of 0.05. By the way, this one actually does have strong statistically significant evidence. If it had been 0.04, you would have statistically significant evidence, but not strong statistically significant evidence. Just want to note that because on the discussion post-assignment, some of you made a mistake on that. All right, so our p-value was again 0.00026. And now we can state our conclusion. Here we have a very small p-value, much smaller than 0.05. So there is statistically significant evidence to conclude that the population mean cooking time for women is larger than the population mean cooking time for men. Any questions on that idea? Always feel free to ask questions. Any questions? Okay, our confidence interval, again, if you go back here, went between about 5.43 and 18.6. So 5.4 and 18.6 will be our confidence interval. Okay, to interpret the confidence interval, we say with 95% confidence, the population mean, population, that word population has to be there. Population mean time single women spend cooking is between 5.4 minutes and 18.6 minutes longer than the population mean time single men spend cooking. Any questions at all on this example? Any questions? So I went through this quicker because once you've seen one, even if it's proportions, the means aren't that much different. Any questions? Okay, the ideas are all the same as last week. Hopefully you noticed that. What's new is now we're comparing two different groups instead of talking about just a single sample, comparing it to a known number. Very different. But the ideas are all the same. Any questions at all on this? Okay, so no questions. Let me tell you an example, a real example, actually. It's kind of one of my favorite examples ever because I made a lot of money off of it. Any guess on what that example might be about? Gambling. Actually, I did make money in statistics, gambling, but not hypothesis tests and confidence intervals, because those you can actually get the exact percents. So that wouldn't really be hypothesis test confidence intervals. That's why I kind of chatted about that in the earlier chapters when we just did probabilities. So let me tell you. and that's the stock market. Okay. Any of you invest in the stock market? Anyone have any experience with it? Okay, maybe not, maybe yes. Okay, so let me tell you, this happened, it was a while back, so sorry if it's a little old history. This was, it was about 6 or 7 years ago. Do you remember who was president 6 or 7 years ago? Hopefully you know that. That's not a hard question. Okay, who was president? All right, maybe you don't remember. It was President Trump. He's running again. Well, one thing I never tell you is who to vote for, whether you should vote for Trump or against Trump. But I will tell you history. One of the things Trump did a lot, if you paid attention, is he would tweet. Okay. He would tweet. In the old days, it was called Twitter. Now it's X, but it was called Twitter then. And he would actually tweet about how he was going to get China, going to give him big taxes and all kinds of things. And what I started noticing is that every time he tweeted about China, the stock market went down. Okay, it was just notice that was happening. So what I did, and I do this a lot, by the way, but this is one of my favorites because it's a fun one and I made a lot of money, is I looked to see if it was just a feeling or if it was real. So was it statistically sound to say that after Trump, the day Trump tweets about China, things go way down, but then within a couple weeks, comes back up. The market comes back up. That makes sense? Okay. And then I went and I looked to see which of the big stocks reacted the most strongly to his tweets. And the one I found that looked like it really reacted was NVIDIA. In those days, people never heard of NVIDIA. Nowadays, almost everyone knows NVIDIA. It's gone way up, by the way. I made lots of money. So what I did is I looked at the stock price of NVIDIA. Again, this was like 7 years ago or something like that. The day of the tweet, so, a few hours after he tweeted versus 1 week after. And I had a small sample size. That's all I had. He didn't tweet a million times. Okay. And if I waited until he tweeted like 31 times about China, he wouldn't be president anymore. I can't make any money. So what I did is I waited until he did it about 6 times. And these are the values of the stock price, tweet day and a week after that tweet day. Something to really notice, and this is important, if you look at this 106 and this 113, they are paired up. This 124 is not 1 week after the 106. Do you see that? So if I change the order, that messes everything up. But given the fact that they're ordered and paired up, that means we have dependent data. Got it? It's really important. That's one of the hardest parts about this chapter, is to be able to look at it and say, do we have dependent data or do we have independent data? This is definitely dependent because this 106 and 113, that was paired up. This 110 and 124 paired up. Do you see how that works? Any questions? You can't switch these numbers around without completely changing what's going on. All right, so the next thing we need to do is we need to state the null and alternative hypotheses. This is a little different than the one we just did because we have paired data or dependent data. So now we're not just looking about the difference between the total means on tweet day and the total means 1 week later, but the paired differences. So we can actually subtract the individual pairs. This 113 minus 106 is 7. This 124 minus 110 is 14. So we can think about this as subtracting the 1 week later minus a tweet day at each pair and looking at that to decide on your hypotheses. So in particular, I'm going to write mu sub d. D is the first letter of difference. So it's the population mean difference between 1 week later and tweet day. Well, if really they have nothing to do with each other, then the difference would be 0, right? If it didn't matter whether you tweeted or not, the difference should be 0. So that'd be mu sub d equals 0. Okay? On the other hand, if 1 week later is higher stock price than tweet day, then tweet day will be, tweet day minus 1 week later will be negative. So we're going to write H1 colon mu sub d is less than 0. Any questions on that idea? Any questions? Okay. And mu sub d is tweet day minus 1 week later. Okay, I wrote the p-value, but let's pretend we didn't see that. What we need to do is we need to get this in the calculator. So let's go to the calculator. Let's go back. And tell me which calculator I need to use. So what calculator? Yeah, this one's going to be number 20 because we have dependent samples, often called paired also. And we have data. Okay, so we have dependent samples with data. And there's 2 dependent samples. So now we got to put the data in, separated by commas. I think the easiest is I'm going to copy and paste this line and then put the commas in. And then copy and paste the next line. Put the commas in. We want less than. Let's do a confidence level of 95%. Let's go 90%. Because with the stock market, hey, if I am correct and make lots of money 90% of the time, I'm happy enough for that. Okay? So I'm going to go 90%. This isn't some publication thing. In fact, I didn't publish it. I didn't want to tell the world because then it doesn't work anymore. This is my money. I told a few friends, actually, because I was hoping maybe my friends could make money. And a couple family members, but I'm not publishing it. So I'm going to go for 90%. And I'm going to calculate. Okay. Here we have a test statistic. It's a t, student's t. Okay, just like we had in one variable, we do t because it's the student's t. The p-value is 0.018. Any questions on that? All right. By the way, 0.018 is definitely less than 0.05, or I'd probably even go 0.1, because again, I'm okay being a little riskier. Okay. So the conclusion is there is statistically significant evidence to conclude that the population mean price of NVIDIA is higher 1 week after the tweet than on the day of the tweet. Any questions on that? Okay, so just to let you know, that will show you there is statistically significant difference, which means we have statistically significant evidence to show there's a difference. So some people will say statistically significant difference. That's not the same thing as practically significant difference, because if the difference was only 1 penny, then to me, it's not worth investing in the market. Does that make sense? So the big question you might ask is not just does it get higher to a week after tweet day, but does it get significantly higher, practically significantly higher, so that I actually make real money? Okay, to me, 1 penny is not real money. Is that clear to everyone? And the confidence interval is going to tell us that. So notice a confidence interval has a lower bound of negative 1342 and positive 224. I'm going to go 2 decimal places. We're talking money. Then it's dollars and cents. Any questions so far? All right, so we can now interpret it with 90% confidence. The population mean price of NVIDIA goes up by between $2.24 and $13.42 from tweet to 1 week later. Okay. Is that practically significant? Like, am I making money if I bought 1,000 shares? And that means I'm going to make between, $2,240 and $13,420 every time it happens. To me, that's real money. Do you agree? What do you think I did after I ran these statistics? Any guess? Any guess what I did? Okay. I invested. That's what I did. I invested. And every time the tweet happened, I bought stock. And then a week later, I sold. And did I make money? Absolutely. Thousands and thousands of dollars. Not millions, because I'm not that rich. But I made thousands of dollars, so it made me really happy. So if you can find a pattern and realize that it's statistically and practically significant, and you can find that pattern with the stock market that other people haven't found, you can make a lot of money. So I always like to give you, suggestions. Okay. Don't like publicize it anywhere, because then everyone will hear about it and you won't make any money anymore because everyone will be doing it. So that's where you have to be somewhat secret, other than, a couple friends and family, and tell them not to tell anyone. Any questions on this idea? Okay. And I actually haven't found a good one like this since then. Biden doesn't do a lot of kind of random calling outs, that repeatedly over a year, that it's really hard to, make money that way. Doesn't make him a bad president or a good president. It just means that I haven't found a way to make money yet. This is not the first one of these I've done. I've been doing these for decades, and I made money lots of times. But this is my favorite and the one I made the most on. Okay. So what I want to talk about, I want to spend the rest of the time, well, before I do that, I want to do one last little thing. And that is the secret word. The secret word is compare. Because chapter 10 is all about comparing two population means or comparing two population proportions. So compare, because we compare in this chapter. So I figured I would give you a word that probably wouldn't just guess, but realize after seeing it that it's really important. Okay, for the chapter. So compare is a secret word. But I want to talk about the project. So first thing, let's go to the syllabus. And when you look at the syllabus, the project's not due. Again, I talked about it last week, but now I get to talk about in much more detail. It's a little less than a month from now when the project's due. It's the 23rd of June. And it's worth the same as project 1. Okay. I've talked about the basics of it already. Don't forget, you gotta have partners. So if for some reason you don't want to be with the same partners, your partner dropped or something, then make sure you post in the Project 2 discussion board. Go find a partner. Very important. Do not wait another 3 weeks before you go look for partners. If you don't have a partner, you should be looking today, finding a partner. Okay, and worry if you don't have one. You need to get partners. Okay, so let's go to the project. I went too far. There it is. And I'm going to click on project 2. Project 2 has some similarities and some differences. Okay, so the purpose of project 2 is to use confidence intervals and hypothesis testing to support or show lack of support for a research project. Okay, so just a note, most of project 2 of your writing should be about the confidence interval, and the hypothesis test that you do. Okay, that is the key to the project. It's not about all the stuff you did in project 1. You could write a few sentences on the other stuff, but most of the project's writing is going to be the confidence interval and the hypothesis test. Got it? Okay. Just like project 1, you got to first decide what you're interested in researching and design your study and collect your data. Just a note, this is not the same as project 1. Project 1, you had to actually survey people. That was a requirement. Here, you have to collect data. And what you can't do is just grab someone else's research paper where they've already done a hypothesis test and a confidence interval, because that's just copying someone else. This is just collecting data, not finding someone else's confidence interval and hypothesis test. This is finding data. Okay? That data does not have to be surveying. It could be, for example, I don't know, if you wanted to find out whether it is, I don't know, colder in maybe Texas than it is in, say, Austin, Texas, on average over the year than it is in Los Angeles, California. I have no clue, by the way. You could easily collect data, go online, find out the temperature on, I don't know, the 4th of maybe the 4th, 14th, and 24th of each month for the last year in California and in Texas, you know, in the 2 cities. I don't know, whatever you might want to do, you can find data. Or let's suppose you wanted to look at, is it cheaper to shop online versus in person? So you can go to some store like Walmart, look at a bunch of items, maybe 31 items in Walmart, go online, see what they cost on Amazon, if you can find the same items, and that's your data. Does that make sense? Any questions on that? So you're collecting data. Okay. And by the way, there's lots and lots of different studies. For example, I did Snapshot Day a few weeks ago where I actually collected the data from the creeks that flew in that flow into Lake Tahoe. Talked about that last week. You could actually go and get that data. Okay. And if you want, send me an email. I'll tell you who to ask. It's not me, by the way. But you can ask the person who is in charge and they'll give you the data. So a lot of people will give you the data. Any questions on that? Okay. A little bit like project 1, you also need to have a client. So you need to identify a client, at least in theory. They ask you if you have a person's name. Okay. who will be making the decisions based on your results. Just like Project One, the audience is the person who would be interested in the results of your study. So that is what you're supposed to do, is you're supposed to find someone interested. If nobody would be interested, then it's not a good project. Okay, then you're going to analyze your data and see what it tells you and whether it supports your hypothesis. Just to note, what you're going to have to do, you do a little short description, not long, on the sampling technique. 1 sentence is enough. You're not doing whole paragraphs on that because that was Project One. Okay. And unlike Project One, you could do any technique. You could use convenient sampling. That's fine. As long as you admit to it, I don't take off points. On Project One, I do, but not on Project Two. And make sure that you talk about it. That's all. Okay. And if the census data is available, so if you could get every single individual that exists without too much trouble, then this doesn't work for the project. So the project is all about needing to collect a sample to be able to really have a guess, an estimate for the population. If you can get the whole population, there's no reason to get an estimate because you can get the exact value. Okay, so if you could get the census, then it's not acceptable. Okay, you also must conduct a comparison study. And here it is with either 2 independent or 2 dependent variables. I did an example 20 minutes ago and 10 minutes ago or so, something like that. On an example with independent, an example with dependent. Okay, you choose one or the other. I don't care which one you choose, but make sure you choose it. And you better, if you chose dependent, you better use dependent data statistics. Okay, similar with independent data. Okay, the variables must be quantitative. Okay, so proportions do not work for this particular project or the other one. As I mentioned, even if you had 300, that's still too small a sample if it were proportions. And that's why quantitative makes much more sense, because then you can get a study of 31, and that's fine. They should be subtractable. What I mean by that is don't even think about like asking people 2 questions. The first question is, how much do you weigh? And the second question is, how much money do you make? Because it doesn't make any sense to say, $60,000 minus 180 pounds, because it doesn't, you can't compare those. Those numbers are not subtractable. Any questions on that? Okay, the sample sizes must both be greater than 30. If you're doing independent data, you're gonna have 2 groups. That means 31 from this group, 31 from this group is fine. Okay, 20 and 20 is not fine. If you're doing dependent samples, that means you might be looking at 31 people and looking at 2 features of those 31 people that are dependent. Okay, or maybe 31 products that are being sold and the prices of those products in 2 different places. Okay, any questions on that idea? All right, let's look at some more. You also have to have a list of the key summary statistics and interpretation of each. When I say key, I do not mean every single statistic there is, but the mean, because the mean is an important one. But the biggie is the standard error. It's a standard error for the difference. Okay, that was a standard deviation of the sampling difference, the standard deviation of the sampling distribution for your sample. Okay, for the difference. Okay, very important. Not the individual standard deviations. They're not important at all. It's the standard error. Okay, and because that's the new one. So that one you should be talking about in multiple places, and I'll talk about that in a bit. Okay, you don't need to go into detail about all the rest of them. Okay, but if you do have a source, then you have to cite the source, just as normal. Okay, and you also must do a copy and paste of the spreadsheet for the confidence interval and hypothesis test statistic listed from the source. And by the way, the spreadsheet must be the spreadsheet that comes from the class. Remember this one, Statistics by Larry Green, it's the same one. So now I popped it in, and if you've already downloaded it, then you've got it. You don't have to do it again. It's already on your system. You have your own copy. The only difference is that in Project 1, you use this 1var stats. Now you're going to click on this 2var stats tab. And then we're going to be looking at that. So the first thing you're going to do is you're going to highlight these A and B columns and hit backspace, just like I just did. Then you're going to put in your data values. That might be, I'm just making up some numbers, 34, 23, 18, 43, 22, 63, 15, whatever they might be. And then for the second would be, I don't know, 44, 55, 29, 37, 38, 41, 40, and 69. Okay, then what you need to do is the important thing is you have to decide, do you have independent data or do you have dependent data? Now you're seeing why I waited until today to talk about it, the project in detail, because this is the first time we're talking about independent and dependent data. So whichever you have, that's the one you're gonna be looking at. So if you have independent data, what you need to do is you need to copy, Control C, and then go to your project paper, Control V, and paste that into your paper. Make sure that's in. Okay, if you had dependent data, same thing. You're going to copy those two columns, Control C, and then paste them, Control V, into your stuff. If it's if it's a Mac, it may not be Control C and Control V. I'm not a Mac user, sorry. That's the idea. Okay, I do want to note I've set it up so that you can very easily change the confidence level. So here we have a 90%. I can make that a 95%. There we go. And it's very simple to find the confidence interval for 95%, 90%, and 99%. Those are the three biggies. Okay. It says p-value two-tailed, p-value right-tailed, p-value left-tailed. That'll completely have to do with what your hypothesis is. If H naught is mu1 is greater than mu2, then you have a right-tailed test. So you're going to use a p-value right-tailed. Okay. If it was mu1 is less than mu2, then it'd be left-tailed. If it was mu1 not equal to mu2, it'd be two-tailed. Any questions on that? You'll also notice if you have independent data, here's your standard error right there. It's there for you. Okay, if you have dependent data, then your standard error is right down there. Okay, and they're going to be important. You got to spend time writing about them. Okay, the mean for stat A is right here. The mean for stat B is right there. So stats A mean, stats B mean. Also, the mean difference is there. Any questions? Any questions on that? Any questions? Okay, so that's a spreadsheet, and that's what you're going to have to use. Just to note, this particular project, there's no charts. This is not project 1. Don't even consider putting in like pie charts or histograms. It's not necessary. It's not part of this project. Okay, this project is all about the confidence interval and the hypothesis test. So And you have to use this spreadsheet, by the way. Okay, you can't use some other thing. Has to be that spreadsheet. So you have to copy and paste that spreadsheet. Let's go back to that. Okay. And then the other thing is you're not looking at the individuals, you're looking at the difference stuff. So a big part, oh, by the way, for standard error, I have a video on standard error if you forgot about it. I'll let you click on that and watch my little video on what standard error is. So you can do a confidence interval for the difference, and it might be a independent, might be dependent, depending on your project. You can do a confidence interval for the difference. Okay, we talked about that today, and hopefully you understood it. And if not, you can get help from the tutor, from me, from each other, whatever, but definitely make sure you get it. Okay, you have to choose a level of confidence. Confidence level and level significance are totally different things. Do not say I'm using a 95% level of confidence because I'm using a 5% level of significance. That's wrong. You don't have to have those match up. Okay, what you should instead do is look at the 90% level, look at the 95% level, look at the 99% level, and look at the pros and cons of each of those. And based on the pros and cons, decide which is best for your client. And you have to write about all that. It's a lot of writing in this confidence interval stuff. The other thing is you should write down what is the lower bound for the confidence interval. Look at the lower bound of the confidence interval and decide what decisions the client might make after seeing that lower bound. Then, separately, look at the upper bound for the confidence interval and decide what decisions that client might make after seeing the upper bound. And there'll be possibly different decisions. Okay? Remember, it's all about the client. Okay? The other thing you might look at is say, well, is it narrow enough? Okay, is it narrow enough so that the client actually is getting good information? If it's a bit too wide for the client, you want it to be more narrow. But if you make it too narrow, one way of doing that is to make it a 90% level of confidence. And then your client might say, well, I'm not okay having a 10% chance of screwing up. So that doesn't work either. So then you would say that it's not that great. So we'd want to have a narrow confidence interval, and you would want a 99% maybe. So then the question is, if you wanted a 99% confidence level with the same margin of error as what you use, which might have been for 95% or 90%, how big a sample size would be needed to make that happen? And remember, that had to do with the standard error, because the standard error is inversely proportional to the square root of the sample size. So if you change the sample size, that's going to narrow the confidence interval or the margin of error. Any questions on that? Okay, we talked about that in chapter 7. Okay, it's been a few weeks, but it was all important. Okay, so that's important. You need to talk about that. And it should be all about your client, by the way. Any questions at all on the confidence interval part of the project? Usually that could be pages long, by the way. A lot of stuff to talk about. Okay, then there's a hypothesis test. We've done that in much more recently, but we also did confidence intervals today a little bit. So then remember, there's an order at which you do things for hypothesis tests. Make sure that in writing your paper, write it in the order at which you do the hypothesis test. Okay, remember that was first deciding on your H0 and H1. You should write it in both symbols and sentences, by the way, for the paper. Okay, then you decide on type 1 and type 2 error. Then you decide which is worse. And then based on that, what should the level of significance be? Then after that, you collect your data. So you could write that part of your project before you even go to collect your data. And you should. You should write those paragraphs first before you collect your data. Then you collect your data, pop it into the spreadsheet program, and then you're going to look at all the stuff we got. Okay? You're going to look at the p-value. You're going to write your conclusion based on the level of significance and the p-value. And then make sure, don't just state it in one little sentence like I've been doing. This should be like a full paragraph of conclusion, because it should be all about what the client is going to do after seeing it. Okay? So it's not just the one sentence. All right? What decisions will the client make after seeing the results? Okay? You should interpret the p-value and think about how that's going to help or hurt the client. All that's important. Okay. After looking at the p-value, is there reason to conduct a new study with a larger sample size? And how big a sample size might that be based on the standard error? Make sure you explain all of your stuff that you're doing, and it should be all about the client's needs. Okay? Do not make it read like it's part of the answer to the homework problem, or just a discussion post. This is many pages, these parts. Any questions so far? Okay. You're also talk about assumptions that you need to make. Okay. And don't get confused between assumptions and conclusions based on central limit theorem. That's the word assumption and the word conclusion are different. You should also give a discussion of why your topic and results are important. That could be like a summary kind of thing. But not just a summary, you should also intermingle the importance and how it's going to be used to your client throughout the paper. Every time you mention anything, talk about how the client is going to use it. And a discussion of how further studies could be done in order to delve deeper into the topic. Okay, any questions? Any questions on that? I also have some past feedback that I've given on other projects that could help you. I don't give full projects because people just copy and paste, but I will give you some feedback on things that went wrong or whatever. Any questions at all on anything about project 2? Okay. I do want to mention you have a while, but here's my recommendation for timeline. Okay. I would recommend that by the end of this week, you get together with your partners. If you don't have partners, that's today. Get partners. Okay. But by the end of the week, I would recommend coming up with an idea for your study. And that would be what your data is, where you're going to, what your data will be. Okay. Not the individual data values, but what's your null hypothesis? What is your alternative hypothesis? Who your client is? And how might you be collecting your data? Once you've decided on that, then you should post that in the project 2 discussion board. And I'll look at it and let you know if that can work for the study. Okay. So make sure, again, without your hypotheses, I can't know. Okay. Maybe a sentence or two on what your plan is. I'll look at it, let you know, yes, it's going to work. Go for it. Okay. And just like before, 3 is best for partnerships. 2 is allowed, 3 is better. Because if a disaster happens and you lose your partner, then if there's 3 of you, now there's 2 left and you're still okay. So that's why I recommend 3. Okay, so that's timeline. Week 1, is get that project idea posted on the Project One discussion board. Okay, I do want to give you a heads up, and no one did it, but I don't know if you remember, but now the weather is beautiful here in Lake Tahoe, and I did it last weekend, and I'm gonna almost certainly do it again this weekend. I'm gonna be backpacking, which means I'm gonna be offline for probably like 30 hours, out in the middle of the forest on top of a mountain with no internet. So don't be upset at me if I don't get back to you on Saturday and Sunday this week, because my plan is to go out backpacking. You gotta allow me to have some fun in my life. During the week, though, I get back to you right away. But just let you know that there are some times that I actually have a life. And I did last weekend too. It was amazing. So beautiful. So just let you know that sometimes it'll take a day or two for me to get back to you if I happen to be in a tent. Because we all have our hobbies. So I won't be gone for like weeks, but maybe 2 days. Okay, so just to note, that's a heads up in terms of, if I don't get back to you in 2 days, that's what happened. Okay, so after I get back to you and say this is great, project's going to work, then collect your data. Okay, if it's going to take you 10 to 15 hours to collect your data, this is a terrible project because you're wasting your time. Unless, of course, it's for work or something and you're getting paid. But this should not take forever to collect data. It should be much quicker. So again, collect some data, make it good. And after you've collected data, maybe, in 2 weeks, then you do your write-up. So you write up your paper, and then just note a reminder again. Let's go back to the syllabus. And that is a project due on the 23rd, which is a Sunday, by the way. When you send me your draft, that has to be done by Thursday at 8 a.m., but better is before. So I recommend, like 6 days before. So that would be like the 17th of June. Okay. Just note the 18th of June is a holiday. Do you know about that? The 18th, or is it the 19th? The 18th of June is a holiday. I think it is. It might be the June 19th, maybe. And I'm going to be backpacking for 2 days. So expect me to be gone for 2 days because I got to have fun too on holidays. So be ready for that. So the idea is maybe a whole week, which would be the 16th of June, send your project draft, and then I'll be able to get it back to you. Okay. Otherwise, it might take a few days because on that holiday, I'm having fun on my holiday for that day. I'm going to do an overnight backpacking trip, unless weather's bad. So just to note that that's going to happen, but I'll get back to you and then let you know, just like on Project One. And I recommend kind of having, instead of saying the deadline's the 23rd, I would in your head, put the deadline to be the 22nd. And that way, because it really doesn't make any difference in terms of your time, whether it's the 22nd or 23rd. But that way, if a disaster happens, it gives you an extra day. But really try and get it done the 22nd so that, got that extra day if you need. And that's a life skill. If you have something really important, don't wait till the last day. Try and get it done the day, at least a day early. That's a strong recommendation because it's not like it's going to make any difference, if it was the 22nd or the 23rd for the due date I put in the syllabus. It's just when you in your head would put it there. So in your head, try to put the 22nd. Does that make sense? And because after the 23rd, it's too late. So you don't want to do that. Okay, and that's pretty much everything about the project. So are there any questions? Okay, if not, then we're going to call it a webinar. Usually we're a little bit short on the webinars towards the end, next few weeks also. I do have a few minutes to discuss after we drop the YouTube part and all that. So I can also answer questions afterwards for sure. But if you have any questions that are public questions, this is your time. Otherwise, we'll say goodbye and I'll stop the recording. Okay, let me stop the recording.